Okay, good morning, everybody, and welcome to this webinar delivered by the HY4RES project. My name is Paul Coughlan. I'm a faculty member at Trinity College in Dublin, and I'm joined this morning by colleagues who are in the research team who are coming to us from different parts of Europe and beyond. I'll introduce each of them in just a few moments. The focus of our webinar this morning is on developing technologies, and it comes within the broader project, which is looking at unlocking the potential of renewables in Europe. The timing of this webinar coincides very nicely with the EU Sustainable Energy Week, and it's part of our contribution to that. This morning's seminar is the first of three. As you'll see on the opening slide there are two other seminars, one in 2 weeks' time and one in 4 weeks' time, but I'll introduce those a little bit later. The HY4RES project began in 2023 and finishes this year in 2026. There are 9 partners, and they come from Ireland, France, Spain, and Portugal. It's a very interesting mix of industry and academic partners, and each of them are working in different settings. And in every sense, it's a wonderful example of transdisciplinary research. This morning, we have 4 speakers, and I'll introduce them in a moment, but they will introduce the policy context within which this research is relevant, and then explore the various challenges in developing renewable energy in Europe and how these systems can contribute to enhancing energy efficiency. But before we begin, there are some instructions, I suppose, guidance for you. The session will be recorded and available for replay. And the slides, all of the slides will be available after the webinar on the HY4RES website. Your microphones and cameras are turned off, but you can ask questions in the Q&A function, and we will be monitoring those as the webinar proceeds, and use the chat for discussions. Now, there's also the possibility to enable transcriptions and live subtitles. And Nina, one of our team members, has put the particular instructions into the chat so that you can see those. And hopefully, if you need an alternate language to English, which is what we'll be using this morning,
hello, bonjour, hola, bon dia. We're working on a European project called HY4RES. We want more of the electricity we use to come from renewable sources. So we've developed hybrid systems that combine renewable energies to compensate variability and provide innovative storage solutions. This makes the production of renewable electricity more stable, sustainable, and less costly. We are testing our systems at 4 pilot sites, working with local partners in different environments to implement small-scale solutions that can be replicated elsewhere. In Spain, we are working with farmers in Andalusia to help reduce dependence on fossil fuels for irrigation. At the port of Avilés, we use tidal power to harness the energy of the sea, and we're testing a mobile hub that can store and regulate the use of energy. In Ireland, our aquaculture site in County Donegal uses surplus electricity generated by wind turbines to dry wood from local forests. In Portugal, we are rehabilitating disused installations in rural areas to produce renewable energy, and our hybrid system will power a small energy community. We are researchers, engineers, business leaders, farmers, and local authorities, and have worked together at European level since 2023. HY4RES project is co-funded by the Interreg Atlantic Area Program of the European Union.
Four of my wonderful team colleagues this morning, Laure Martin from Vertigo Lab, Aonghus Mc Nabola from Trinity College in Dublin, but also RMIT in Australia, Rodolfo Valdés at the University of Oviedo, and last but not least, Naufal Riyandi at Trinity College Dublin. They will each take a different perspective on the project. And so we begin with Laure. And Laure has a PhD in international economics and a degree in agricultural engineering. And this dual background has enabled her to develop a multidisciplinary and holistic approach to the development issues involved in this particular area. Her areas of expertise include, amongst others, agriculture, agroecology, and public policy evaluation. And it's looking at the policy context and challenges that Laure will take us through for the next few minutes. Laure.
Thank you very much, Paul, for the introduction, and welcome everyone. So I have a few minutes to present you the policy context for renewable energy development in Europe and in the 4 countries concerned by the HY4RES program, which are France, Ireland, Portugal, and Spain. It's going to be a very brief presentation, and it's going to be far from exhaustive, but it aims at understanding the European context, see how it is translated into national energy and climate plans, and identify the opportunities and challenges for the deployment of hybrid renewable energy. Oh, I have. Okay, so we'll see the European framework first, and then we will look at the national energy and climate plans in each country, and we will detail Spain in particular. I'd like to start very quickly, and I'm going to spend a couple of seconds on some key concepts and vocabulary to help us understand the policy landscape in Europe. So in Europe, you have 2 main legal instruments, which are regulation and directive. First, the regulation, they apply directly and automatically in all member states, while the directive are more flexible because they define objectives to be achieved in each country, but they leave some flexibility regarding the implementation in each country. If we look at the general directive and regulation history in Europe, we see that it started more or less in 1997 with the Renewable Energy White Paper, which established the first EU-wide objective, which was increasing the share of renewable energy to 12% by 2010. At that time, renewable energy was mainly seen as an environmental and diversification tool. During the year 2000, there were more concerns about climate change, energy security, and dependence on imported fossil fuels, which led to stronger ambition. So, for instance, in 2007, the European Council adopted the 2020 targets. It was called this way because it includes an objective of 20% renewable energy to be achieved by 2020. This objective was then translation in a directive in 2009, the Renewable Energy Directive called RED I. The next major step was the revision of this RED I and the adoption of the RED II directive, increasing the renewable energy target by 32% to be achieved in 2030. And then there were 2 major turning points. First, it was the European Green Deal that was launched in 2019, which established the objective of climate neutrality by 2050. The second was the energy crisis following the Russia invasion in Ukraine in 2022. This led to the launch of the REPower EU. It's a strategic plan designed to reduce the dependence on imported fuels. It will be presented in more details a bit later in the next slide. This plan, the REPower plan, led to the revision of the RED II, leading to the adoption of the RED III the Renewable Energy Directive in 2023, which is the directive that is in place currently, and we will present that afterwards. So you see here that the renewable energy policy in Europe has evolved from an environmental objective in the late 90s to a more strategic pillar of energy security and industrial competitiveness nowadays. The RED-PowerEU plan and the RED III directive are the latest and most important manifestation of this evolution, which is why I will detail them in the next slide. So if we look at the energy security and the launch of the RED-PowerEU in 2022, the idea was to diversify the energy supplies, to accelerate the renewable deployment, to reduce the fossil fuel dependence, and to simplify permitting procedure for renewable energy projects. We see a shift in the priorities. Climate remains a central objective, but now it's increasingly also focused on industrial sovereignty and competitiveness. Through the acceleration of offshore wind, the hydrogen development, grid modernization, and energy system flexibility. And we also see that with the new commission that was put in place in 2024, the Green Deal becomes less of an environmental transformation and more of an industrial decarbonization and strategic sovereignty. So if we look at the different targets that are set in the EU. The idea here is to combat climate change, improve energy security, reduce the GHG emissions, and improve the industrial competitiveness, as I said before. The main target that we have regarding linked to renewable energy is the climate neutrality that should be achieved by 2050, which means that at least 55% reduction to be achieved by 2030 compared with the 1990 levels. This, in terms of renewable energy, in the latest directive, as I said before, the Renewable Energy Directive, the RED III, for the ones that are very familiar with the directives, this RED III says that the target goes from 22% to at least 42.5% renewable energy in the final energy consumption by 2030, with an ambition to reach 45%. So we have these targets that are set at European level, but although we have those common objectives, each country remains responsible for defining its own pathway, and according to the reference situation in each country, you have national targets within the EU that might be different from one country to another. So in this graph, you see the target that the country sets for themselves. In blue, you have the target set for each country by Europe, and the point represents the global target for Europe in general. So you see that you have some good students and, well, less good students, such as France, for instance. The idea now is to present you what is happening in the 4 countries concerned by the HY4RES program in order to understand what is the political environment where those innovations are being developed. We don't have a lot of time, so I'm sure you would love to have a presentation for all the different countries, but we decided to present you in detail more the Spain project. And then we'll go very quickly over the other countries if we have time. Otherwise, you will have the presentation and you'll have a complete report by the end of the year also regarding the policy context for renewable energy in each country. So why Spain? Because Spain is one of Europe's renewable energy leaders. Indeed, the target set for Spain is that the country aims to reach approximately 48% renewable energy in gross final energy consumption by 2030. And renewable energy should represent more than 80% of total electricity generation making Spain one of the most ambitious countries in Europe. Same goes for Portugal, but those two countries are the most ambitious in Europe. If we look at the installed capacity, we see that Spain relies a lot on solar photovoltaic and wind power. Indeed, you have 39 gigawatts of solar photovoltaic, 62 of wind power, and 3 gigawatts of offshore wind. Indeed, Spain benefits from exceptional natural conditions, combining some of the highest solar irradiation levels in Europe with excellent wind resources, which is why we have those two renewable energy more developed in the country. And this combination has enabled the country to become one of the most competitive renewable energy markets in Europe and a major destination also for renewable investment. If we look at the SWOT analysis, so SWOT is an acronym for strengths, weaknesses, opportunities, and threats. We see that Spain has a lot of potential. In fact, there are very few countries combining such high solar irradiation with excellent wind conditions, as we said before. Moreover, Spain benefits from a major renewable energy ecosystem and strong investor confidence. However, there are also some challenges. For instance, the grid saturation is becoming an issue in several regions, and the competition for grid connection is increasing between the different projects. Moreover, administrative procedure can also be complex due to the involvement of both national and regional authorities. Looking at opportunities, Spain is becoming a laboratory for hybrid renewable systems, combining different technology. And there are still some risk because indeed climate change and recurring droughts may affect hydropower, for instance, and water availability. There are also land use conflicts and local opposition that are becoming more visible as renewable energy deployment accelerate. Overall, Spain offers one of the most favorable environments in Europe for hybrid renewable energy project. But the future development will increasingly depend on storage development, grid reinforcements, and territorial acceptance. I look at the time and I see that I have a very few minutes left. So very quickly, if we go through the different, through the other project, we see that France historically has a very diversified renewable mix alongside historically low carbon electricity system due to the nuclear power plants in France. We also have quite a lot of issues regarding procedures and local opposition in some areas. Ireland has very ambitious electricity target as well, and wind energy is the cornerstone of the strategy in Ireland. The challenges there is now ensuring that the grid infrastructure and storage solution can keep pace with the renewable deployment. Finally, for Portugal, same as Spain, because Portugal combines strong solar resources, but also with significant hydropower. So the country is increasingly positioning itself as renewable energy and grid hydrogen hub. However, this development is really dependent on climate change, and it could be affected by recurring droughts in the country. That was very quick presentation, but we see that the different countries have different targets set by the European Union. They have also developed different plans and pathway also to reach the targets that are set for the countries, but they also face some similar challenges, which are the permitting procedures, the electricity grids, and also the storage solution and maintaining the public acceptance. This is the context where the different HY4RES innovation and project are being developed. And I think it's quite important to understand this context to see how we can better deliver and install the different innovation. And just a key takeaway, it's that the renewable energy development in Europe is no longer driven only by climate objective. It is now shaped also by competitiveness, industrial sovereignty, and energy security linked to geopolitical resilience. I hope I'm in time, Paul, but thank you very much.
Laura, many thanks. You're right on time. And thank you for a very clear outline of the policy landscape within which renewable energy is relevant. But you also highlight the increasing level of targets and the ambitiousness of those targets. And I guess one of the things is that features in your presentation is that there are individual sources of renewable energy. But of course, our challenge is how do we blend them or hybridize them, to use a word, how do we blend them with each other and create hybrid renewable energy systems? And I guess that is where the HY4RES project fits in. So it's a good time to move to our colleague, our team member, Professor Aonghus Mc Nabola. Aonghus is Professor of Energy and Environmental Engineering at RMIT University in Australia. But when the project began, he was a Professor of Civil and Environmental Engineering in Trinity College in Dublin. Aonghus is a civil engineer by training, and he has been doing research in this area for very many years. Aonghus is going to introduce to us the HY4RES project as a response to the policy challenge that Laure has outlined for us. Aonghus.
Thanks, Paul. Yes, so that's a good way of summarizing my task today as well. What is the HY4RES project about? And we can think of it in the context of the research response to the policy target. So the HY4RES project, as is mentioned there, is HY4RES is an acronym for Hybrid Solutions for Renewable Energy Systems. And the video in the beginning gave a good overview of what is involved in that. But really the hybrid renewable energy systems is a very broad topic, and we have a particular focus, both geographical and in terms of scale, trying to achieve net zero Atlantic area communities, which is our geographic scale, and also for energy communities and consumers, which hints at the smaller scale power outputs is where we are targeting. So I'm just going to introduce what the challenge that the HY4RES tries to address, the objectives of the project, how we go about it, and a little bit on our partnership. Okay, so Laure pointed out the policy challenge which the Commission has set for us, various targets around having greater levels of renewable energy, and the reason for that hopefully is obvious to everyone. We want to have lower emissions, reduce impacts of climate, and more recently have a more resilient energy system, more energy independence from various imports. So those are our good ambitions, and we can see that in the chart on the left we're making good progress towards that, but doing so brings some challenges. So having a 45%, for example, renewable energy penetration means we have less conventional energy penetration, and that renewable energy variability, being that we cannot always rely on solar panel or solar power or wind power, creates problems. And as Paul mentioned at the start, the HY4RES project started in 2023 and is more than 2.5 years through its 3-year work program. So we are coming to the end of what we planned to do, and you'll see in some of the other talks today some evidence of the work that we have done. But during that time, we had a very high-profile event in Spain and Portugal with power outages related to grid instability that high penetration levels of renewable energy can create if they're not properly managed. And so that proper management of renewable energy in the micro community energy space is where we are targeting. So elaborating on the problem we were trying to address a little bit more. we have more and more renewable sources in the grid over the last few years, and expect that to continue to be the case. Less conventional energy supply, but also a greater demand for electricity in general. We all see data centers in the news and various other reasons why our energy demand is going up. We also have a greater demand for electricity. So not only more variable renewable energies in the electricity grid, but a greater demand for electricity for other environmental policies, such as the electrification of transport and heat, lowering emissions in other ways. So that means that the challenge of managing the grid, which must always meet demand, it becomes more and more difficult, right? So if we think about the dreadful event of a blackout, well, it's not something that happens very often. And so the challenge of someone managing an energy grid with sources which are much more variable becomes much more difficult in the modern era. So that also is a more of a stark challenge in rural areas where the grid is generally weaker. And so what essentially we mean by that is, if you think of the grid or the arteries of our electricity system as they spread to rural areas, they tend to be towards the end of the line, and the capacities are smaller to carry local energy. And so it's a different challenge to manage that variable renewable energy sources there than it is in big cities. And that is where HY4RES focuses, that hybrid solutions at local community level. There is also a geographic dimension, as I hinted at the start, to this problem. So we are part of the research response to the policy position here through the Interreg Atlantic Area Programme, which has a focus on largely rural areas in the Atlantic area of Spain, Portugal, France, and Ireland. And the amount of renewable energy resources in terms of wind and solar and hydro are different in those places. So the same solution doesn't work in all of them. But one of the common challenges which we need to come up with for all three is really focusing on the management of that renewable energy. So not necessarily on the design of a new wind turbine, but the management of that power. So we focus heavily on digital solutions to allow us to manage different sources of renewable energy together. And then we also focus on the design of those systems such that they are low cost and affordable, right? So the affordability of renewable energy is an important aspect of the just transition and other considerations which we have to keep sight of. Okay, so for that reason, a focus of the project is on the demonstration or development and demonstration of hybrid renewable energy systems. We focus on low-cost sustainable energy storage, and also balancing the variable amounts of wind, solar, and hydropower that are available in different settings. And to make the project have an achievable 3-year remit, we focused particularly when we started the project in 2023 on 4, let's call them energy sectors, which were common across the 4 countries involved, and of economic significance. So that being agriculture, ports are obviously a large part of the Atlantic area, aquaculture, and community energy schemes. So we focused our development of hybrid renewable energy system design and energy management on those areas. Okay, so coming up next, yes. So the project is going to focus again, as I was mentioning, on low cost and sustainable power systems. It also includes the development of an intelligent energy, renewable energy management software system, which we're not going to hear an enormous amount today, but later in this series of webinars we will get into. Today we'll focus more on the demonstration of the technology. So the project research on the technical side had two main focuses. One on, first, if we were to take a hybrid renewable energy system that involved solar, wind, energy storage, and hydro, like the icons here, how would we design that? How would we size it in different settings? And then once that's in place, once it's sized for the appropriate resources of those energies available in the location. How we manage that effectively through data monitoring and then management of how much of each power to use. So a key part of the project, aside from desk-based research, was also to do this in practice through demonstrating the technology to show people how we could install low-cost sustainable technologies, and what the viability of that would be, and what were the technical challenges, and so on and so forth. And again, the video at the beginning showed how we were doing that, and so here's again a short summary of these. So we plan to have 4 demonstration sites, each covering the 4 energy sectors we were dealing with: community energy in Portugal, agriculture in the south of Spain, ports in the north of Spain, and aquaculture in Ireland. Or 4 demonstration sites, which are all up and running at this point. And I think in one of today's presentations, we are going to hear about one of those, the port. Okay, and so a final purpose of doing that demonstration was also to grow a community of practice within the project's broader remit, and as well as in each location, to enable the co-design of these solutions and co-development with the communities involved. Again, for really embedding the ideas and the future sustainability of the concepts after the project finishes later this year. Okay, so the activities involved in doing that over the last 2.5 or 3 years, like many European projects, involved a number of work packages. These are sort of nicely summarized here, but essentially all working towards the development of, starting perhaps at the bottom, the development of new technology and software, focusing mostly on the design of hybrid renewable energy systems. Again, if we think of that as trying to size appropriate technology for the available resource, that involves wind, hydropower, solar, and so on, and storage. We'll hear today a little bit about some of the hydropower design aspects from one of the later speakers. In one of the later webinars, we also focused then on a lot on the, let's call it the octagon on the top, or hexagon at the top, which is the management of that software, or management of that renewable energy production once the system is in place. We then try to demonstrate that in the 4 pilot plans, as I mentioned. We also conducted in-depth environmental and sustainability impact assessment on each one, right, to measure the life cycle impact and the social impact of these interventions. And throughout all of that, we had a community of practice to co-design the technology. Okay, now, last of all, Paul mentioned at the start that we were quite an interdisciplinary team of partners. There are a little bit more on us here. So we are 9 partners. Trinity College Dublin was the lead partner. We have the University of Cordoba in Spain, AC3A in France. Well, maybe if I think, since I have 3 minutes, mention what each partner brings. But Trinity College Dublin had significant experience in leading European projects, as well as in hydropower and the concept of using communities of practice for research translation. University of Cordoba are leaders in irrigation technology, and also the energy efficiency of that. AC3A, based in France, have some expertise in the agriculture sector, particularly reaching stakeholders in that area, and science communication in general. And they are helping us with this webinar today. Thank you to the AC3 team. University of Oviedo in the north of Spain bring expertise in small hydropower systems and renewable energy in general. For Agua, our representation of the irrigation community as an industrial association. Easy Hydro in Ireland, a company involved in hydropower production and design. IST in Lisbon, University in Lisbon, with expertise in water systems and hydropower. IG Energy, also in Portugal, a small company in renewable energy systems. And finally, Vertigo Labs in France who lead our life cycle assessment and environmental and social impact work. And I think that brings me to the end. Thank you, Paul.
Aonghus, thank you very much for the fascinating overview of the project itself. And I hope that our audience now is beginning to appreciate how HY4RES as a project is responding to the challenge, the policy challenge that has been set for us. One of the features in the project has been the application of renewable energy systems in a number of different settings. Each of them has combined a number of renewable energy systems, but one of the features, and we're going to major on, as the Americans would say, we're going to focus on port operations in just a moment in the next presentation. And that will feature not just the way in which renewable energy systems in a hybridized way can be designed and installed, but also a sense of modularity, which assists very much in replication and scaling of the solution. So to hear all about that, Professor Rodolfo Espina Valdés from the University of Oviedo will take he'll talk us through portable hybrid renewable energy generation system. And Rodolfo specializes in hydraulic engineering, renewable energy systems, and computational fluid dynamics. He has under his belt more than 15 years of professional experience also in the water sector, covering design, construction, operation, and optimization of water supply and sanitation systems. He's currently the local implementation lead for this project, and he's focused on hybrid renewable energy solutions for achieving net zero energy consumption in Atlantic communities, but with specific focus on the port of Avilés. Rodolfo, I hand over to you.
Well, good morning, everyone, and thank you very much for the invitation. In this short presentation, I will introduce the HY4RES pilot developed in the port area of Avilés, which focuses on a portable hybrid renewable energy system. The main objective of this pilot is to design, implement, and validate an energy generation system based on hybridization of different renewable energy sources with a key feature that is the portability. The idea is to develop a solution that can be easily deployed in environments such as ports, industrial areas, or remote locations where energy availability may be limited, variable, or dependent on conventional sources. In the Avilés port, we developed a hybrid energy hub that combines several technologies. As you can see, we have a nice natural port in Avilés. It's a very industrial zone. And in one side of the port, there is a river that comes, and we can use the stream of the river and the movement of the tidal, and we can get some part of our energy by the hydrokinetic. So the overview of the pilot, in the Avilés pilot, we developed a hybrid energy hub that combines several technologies, for example, the solar photovoltaic energy, the wind energy, hydrokinetic energy, and a pump-as-turbine system. All these technologies are integrated into a unified system. In addition, the project is not only focused on energy generation, but also on monitoring and smart energy management using IoT technologies and communication protocols such as MQTT. One of the most important aspects of the pilot is its multi-resource approach. The port environment of Avilés is particularly suitable because it provides access for solar radiation, coastal wind conditions, the water flows by the river and tidal, and hydraulic infrastructure. By combining these resources, we can improve system robustness, reduce intermittency, and increase overall energy availability. Regarding the photovoltaic system, it includes 3 solar panels with a total power of around 0.81 kilowatts. The estimated production is about 1.95 kilowatts hour per day, or approximately 567 kilowatt hours per year. The system can operate in 2 modes: standalone, using battery storage, or hybrid, connected to the electrical grid. All energy parameters are monitored in real time through the IoT system. About the wind subsystem. For the wind energy component, we install 3 vertical axis wind turbines. This type of turbine is particularly suitable for port or urban environments because it shows better performance under turbulent wind conditions and lower visual and acoustic impact. In terms of performance, total power is around 67.5 watts, and the annual energy production is approximately 473 kilowatts hour. Again, this subsystem also operates in a standalone or hybrid mode with full monitoring capabilities. In case of the hydrokinetic energy, we deployed 2 turbines on a floated platform. This solution allows us to harness water flow without requiring large infrastructure. The energy output is more modest. Total power is about 20 watts, and the annual production is roughly 135 kilowatts hour. However, its value lies in resource diversification and its ability to operate continuously under suitable conditions. Another innovative component is the pump-as-turbine system. A conventional pump is used in reverse as a turbine, integrated with a water tank. The system serves both as a generation unit and a form of renewable energy storage. It provides around 200 watts of power and about 140 kilowatts hour per year of energy production. All these subsystems are integrated into a hybrid architecture that includes multiple renewable sources, battery storage, and of course, capability for grid connection. This allows us to optimize energy usage depending on resource availability, demand, and system conditions. A key feature of the pilot is digitalization. The system incorporates an Internet of Energy layer, which enables wireless access to data, real-time monitoring, tracking of visible such as power, production, and sister status, and we are also exploring advanced functionalities such as predictive maintenance, operational optimization, intelligent hybrid energy management. And like the conclusion, in summary, the Aviles pilot demonstrates the feasibility of a system that is hybrid, modular, portable, and based on multiple renewable energy sources. These types of solutions are especially relevant for port environments, industrial infrastructures, and scenarios where energy resilience is critical. Furthermore, the integration of digital technologies enables the transition toward smarter and more efficient energy systems. And with this, I conclude my presentation. Thank you very much for your attention, and I will be happy to answer any question. Thank you very much.
Rodolfo, thank you very much for an excellent and very visual explication of your activities in the port of Aviles. You know, what I think you have done is not just demonstrated what has been achieved in the port in Aviles, but also demonstrated platform thinking, which is at the heart of modularity as well. And what that means is that the solutions that are being evolved here are replicable and applicable in other settings, which is terrific. So in our next presentation, and this is our final one before we have a panel discussion, where the audience are invited to insert questions into the Q&A, and we can put those questions to our presenters. But in our final presentation, we go a little bit deeper and focus on one particular component of these renewable energy systems. Now, of course, the objective in implementing renewable energy systems is to reduce the environmental impact of the energy that we require to run our daily lives. But of course, the systems themselves can have a negative impact on the environment. And this is where the focus on a fish-friendly turbine comes in, so that in order to recover energy in particular settings, how do we minimize the impact on the local environment? Naufal Riyandi is our final speaker, and Naufal is a PhD student at Trinity College in Dublin, specialising in hydraulic engineering and computational fluid dynamics. He spent over 5 years working in the renewable energy sector, where he has been involved in the design and development of solar and hydropower projects. In HY4RES, he's focusing on the development of fish-friendly pump-as-turbine technology. So Naufal, I'll hand over to you.
Yeah, thank you so much, Paul, for your introductions. So good morning, everyone. So in these sessions, I would like to share our work on the fish-friendly pump-as-turbines, a technology that possible can enable the energy transitions while preserving the river connectivity. So firstly, I would like to start with the regulatory context, which motivates this research. Previously, Laure already mentions about the energy directive target. So European unions have at least 42.5% renewable energy in the energy mix by 2030. Yet in 2024, the renewable energy is still only around 20%. This indicates that we need more renewable energy penetrations, which one of the viable options is the hydropower. Because the hydropowers offer a stable energy productions that can possibly balancing the grid in order of the intermittent issues from the wind and solar energy. But at the same time, the European Union have also natural restoration regulations, which requires restoring freshwater ecosystems and enhancing river connectivity by removing barriers along 25,000 kilometers of rivers by 2030. And this barrier removal is quite relatively complex and costly. And also when we want to remove the barriers, it means that we can losing hydraulic head, which eliminates micro hydropower potential at several sites. So based on this one, we need a technology that can support both renewable energy penetration and also the natural restorations at the same time. Yeah, so now I would like to talk about the hydropowers. So the hydropowers is the low emissions and grid for the grid balancing. However, for the conventional hydropowers, it can block the river flows and threatens the aquatic life. One of the components that quite significant impact to the fish life is conventional turbines. The turbine's blade strike can cause direct physical injuries. Pressure change can lead to barotrauma, and the shear stress also can add further harm. And also, beside the conventional turbines, there is another technology that can generate energy at the hydropower systems, which is the pump-as-turbines or PAT. The PAT itself is a pump that can work in a reverse mode as a turbines. Comparing with the conventional turbines, the PAT is a dual machine, so it can generate energy and also supplying water needs. And also the PAT is micro hydro suitability, and comparing with the conventional turbines, the PAT is a low cost and commercial ready technology. However, for all of the technology that I mentioned, still have the high fish injury rates. Like here, the Francis turbines, it can have fish injuries up to more than 90%. I mean, well, the PAT up to 74%. So in these times, we need a fish-friendly design to adapt it into the hydropower technology. So what is the fish-friendly designs? The fish-friendly means that we allow fish to pass through the machine safely with minimal injury or mortality risk. This designs requires avoiding sharp blades geometries, and then the turbine or the design can be operated at the low rotational speeds. And as you can see that at the right side of the slides, based on our literature reviews, the conventional turbines or the PATs can cause serious harm like physical wounds and scale loss, fin tears, and internal injuries. That's why a fish-friendly designs could reduce this risk and improve the environmental acceptability of the micro hydropowers. And also using the fish-friendly designs, we hope that it can enable deployment at ecological sensitive sites and also directly supports the EU nature restoration regulations. So for the technology that we are focusing on the centrifugal screw pump-as-turbine or CSPAT as our fish-friendly technology. So the CSPAT itself is a centrifugal pump, but with a screw-shaped impeller that operated in the reverse to generate the energy. CSPAT was originally designed to transport water and live fish without causing harm. So the fish friendliness is built into its designs. We can see that from the ill injury rates in pumping mode have been reported at least less than 3%. However, why we choose also this CSPAT is besides the fish friendly designs, it also have a low cost and commercially available. So it possibly will suit as a barrier modification strategy under natural restoration regulations. However, until this research, its turbine performance had never been studied. So within the HY4RES project, we conducted the first comprehensive study of centrifugal screw pump-as turbines with combining one-dimensional analysis, laboratory experiments, and CFD simulations. With the goal that we want to know the CSPAT performance. And in this project, firstly, we tested 3 variants of the CSPAT, the 2 smaller units, which are CSP1 and CSP2, and 1 larger unit, which is CSP3. And our key finding, based on our research, is that the CSPAT is technically possible for micro hydropower adaptations. And the CSPAT itself can generate up to 12.5 kilowatts with the efficiency around 33% with the larger size, which is CSP3. And the performance, we can see that it's lower than the conventional PATs with excess 60%. But this result is a meaningful result for a previously uncharacterized technology. And we can see that also for the rotational speed, all of the units operated at 800 RPMs, which a deliberate trade-off that reduces fish injury risk at some cost to the efficiency. We can see that also the performance also highly sensitive to flow rates, heads, and rotational speed. So we need to be careful if we want to choose the sites where we want to apply this technology. So connecting to policy, so the CSPAT itself potentially enabling technology for sites where we need energy and also we need ecology restorations. And it can contribute to EU's 42.5% renewable energy targets. And also, we know that, sorry, yeah, this is the slides. Sorry, and we know that the alternative for the barriers removal, because of, the removing the barriers, it also have quite high costs. So we need some alternative, which is we can use this technology as a barrier modifications. And also when we already doing the barrier modifications, this technology also can support the river connectivity, and also because of it can support the river connectivity, it can support the ecosystems, so it has the low impacts to the environments. Yeah, to conclude that the CSPT is a potential pathway for sustainable hydropowers, and it can serve as a barrier modification strategy, which can generate up to 12.5 kilowatt at around 33% efficiency, while maintaining river connectivity and preserving aquatic ecology. We can see that the performance is currently lower than conventional PATs, but there is clear scope that for the improvement through designs optimizations. So yeah, we can conclude that fish-friendly PAT is potentially clean technology for generating clean energy from the rivers without compromising ecosystems that those rivers supports. I think that's for the presentation. Thank you so much. Back to Paul.
Naufal, thank you for a very clear outline of some of the detailed work that you and colleagues have been engaged in. So at this point, maybe I would ask Amandine to stop sharing the screen, because we're going to open up for some panel discussion, and then ask Aonghus and Laure and Rodolfo to flick on their cameras and microphones. And yes, thanks, Amandine. Ask your questions through the Q&A. And I see that there's a question came up already, which we'll address in a moment. So Amandine, maybe you could just stop sharing the screen so that we see our colleagues. Yeah, that's better. Thank you very much. So in terms of questions, I saw that there was a question came up immediately for Naufal from Calvin Stephen. Naufal, you mentioned that CSPAT can generate up to 12.5 kilowatts of power. What performance does that coincide with in pump mode?
Okay, thank you so much. Yeah, thank you so much, Paul and Calvin, for the questions. For the performance in pumping mode, to be honest, we just know for the smaller units, which is it needs powers around 5 kilowatts for the smaller units. But for the largest unit, which is have the powers up to 12.5 kilowatts, we still doing the research in the pumping mode, because of currently we just focus in the turbine mode. So for now we're still doing the research for the pumping mode. So maybe we'll let the firm know for what kind of performance in the pumping mode for all of the CSPAT, and we can publish it in the HY4RES website, perhaps, if everything is done.
Very good. Thanks, Naufal. So while I'm waiting for some of our audience to put questions into the Q&A, and we'll monitor those, maybe we'll just start going back to Laure. Laure, you gave us a wonderful tour around the policy landscape. And what kinds of changes are in prospect that will accelerate the deployment of renewable energy systems like this across Europe?
Thank you for the question, Paul. As we have seen in the presentation, that most countries face the same challenges, in terms of permitting procedure, grid expansion, and energy storage. So I guess that the main changes that would accelerate the deployment of renewable energy across Europe would deal with those aspects, and even more so for hybrid energy, because it's already complicated to implement only renewable, but when it comes to hybrid energy, it's even more complicated. So I think this is something where the policy should work on. And I also wanted to add, because you said, Naufal, also that we have also challenges with the environment. So this is also something we have to deal with. and to make our policies coherent in terms of environment and also energy, so that we advance on both sides and not one against the other. So this is quite important. And in a more general context, I have to say that the current context is very sadly favorable for renewable energy development, no? With the geopolitical tension, including the war in Ukraine and the instability in the Middle East, we have seen the high dependence of Europe on imported fossil fuels. So we really need to work on that to gain greater energy sovereignty. And at the same time, as you mentioned, Aonghus, the electricity demand is expected to increase significantly. And you mentioned that already with the data center. For instance, in Ireland, I think the energy consumption, the data centers account for 21% of the energy, electricity consumption in Ireland. So this is huge. And this is where renewable energy and hybrid renewable energy, because it's dealing with the storage issue as well, play a very important role, because those are energies that are able to be implemented quite quickly compared to the nuclear power plants that we have in France, for instance. This is really a good setting, and we should work on that also on the policy level. And on the final note, very quickly, we also have to be aware that with the challenges that come also with the renewable energy, with the deployment of solar panels, turbines that requires large quantity of critical material, and we don't want to switch from one dependence to another. So there's also something to be done about the political efforts to diversify supply chain, strengthen recycling of the material needed for renewable energy, and improve the resource efficiency and develop the domestic industrial capacity.
Thank you, Laure. And just before I maybe take one of your questions onwards to Aonghus, as academics, sometimes we talk about research-informed teaching. Are we in a space from a policy point of view of having research-informed policy making? And in other words, is a project like HY4RES one that has a real contribution to make to some of these policy challenges?
Yeah, I think so, because we do, you can talk about theory and general policies and everything, but then when you have innovation and you can prove that is cost effective, that it's also efficient, this is how you convince also political deciders, political decision maker to make the move and show that there are some solutions. So those projects are really, really important.
Yeah, thank you, Laure. And so, Aonghus, we've heard from Laure in a sense from a top-down point of view, bottom up, from the trenches of the project itself. What role do you think that these systems that we're piloting and linking, what role can they play in strengthening energy security under the growing climate and geopolitical pressures?
Good question, Paul. So I think if you stand back and look at the focus of HY4RES is, as I mentioned, on community scale energy and interventions in rural areas, rural areas that are quite different. Rural Ireland and rural Spain are rural but different. I think that individually they're all quite small systems, and one of the questions in the chat even relates to the size. And so, on an individual basis, they make a very tiny impact on the geopolitical dimension and the targets. However, I think one of the things that's nice to be involved in the HY4RES project, but also a powerful aspect of it is the kind of the community of practice and the ownership that we see in these demonstration projects. And we've had individual visits to 3 of the 4 now, and I can recall being at the one in the port of Avilés, and how passionate the people on the ground are about them. And you can see that in my broader experience of EU research over the years in community energy projects. Really do show that communities can mobilize. And I think also why that's important is that sometimes the policies don't necessarily think about the end of the line in the rural area. And I mentioned in 1 or 2 of the points in my slides, the weak rural grid is not necessarily set up to support electric vehicles and wind energy and solar panels and so on. So I think we have an impact that is local and community based, but there are lots of those, and the key to the longer term impact is the replication of that beyond the 4 pilot plants.
Yeah, in every sense, the demonstration effect that comes from a project like this. And as you speak about scale, and I'll move to Rodolfo in a moment, but as we speak about scale, you remind me, Aonghus, of the kind of thinking that featured around lean in manufacturing, where there was the saying, searching for the last grain of rice in the lunchbox, as the Japanese used to do it, and looking at that, it's a very small scale, but then seeing that if we can replicate that in different settings, then the multiplier effect should increase the impact, the beneficial impact for our communities and our society. So Rodolfo, you've been working very much with modularity, with something at scale, but also portability. Why did portability come onto your radar as something worth investigating and demonstrating?
That was the key of our original idea, to get something portable that we could fit in a container, and then we can move wherever we need. So the idea is to bring the source of energy to the consumer, but not to bring it as much close as possible. So in this case, we bought the container with the idea that we only can use whatever we can put inside, because we are limited by the transport of the container because of the size of the road or whatever. So in our case, the scalability is not so powerful. We have a limitation from the space that we can use to transport all the system, but the idea is to help situations where there is problem with energy. For example, any kind of a disaster, natural disaster, or rural areas, or even island that they are isolated, and we can deploy the container with all the systems inside and give a light of energy to the people that in that moment need the power.
Very good. And Rodolfo, a question that has come from our audience builds on that and inquires into the scalability of the solution. So I understand the container. I've been in the container,
yeah.
And it's terrific to see and how it's working. But how scalable is that? Is it a matter of, is there more capacity within the individual containers to take on board the various systems that are there? Or is it a case of, well, look, we'll need a multiplicity of containers to port a solution, to bring a solution into a use environment?
The limit is how you transport the container. If you use a ship, you can use a bigger container, but we thought about using roads to reach everywhere. So the road has a limited space to move. So this is our limit. But if you forget the portability, you can get as much solar panels as you want, as much wind turbines as you want, but always depending on the source. How is the source that you got in all the different points that you are studying? So if you have a lot of sun, I recommend to buy not only 3, but even 30 or 300 solar panels. If you are in a wind zone, you can deploy as much turbines as you want. So if we forget portability, the scalability, it's never ending. You only have to adapt your system to the sources. But if you want to make it portable, you have the limit depending on the system that you use to move the container.
Very good. And Rodolfo, just in the way in which you've presented your response there, you're doing a very nice trailer for our second webinar in 2 weeks' time, because really it's around what you're articulating as some of the decision making that's involved in thinking about the application of renewable energy systems and how there are choices in the scale of the different elements that are going in there. Carlos Jose Silva has a question in the chat, which he's directing at Aonghus and Rodolfo. And what he says is, I'd like to hear from Aonghus and Rodolfo on the feasibility of scaling up this kind of project for collective self-consumption and energy communities in remote villages using an ecological island approach, thereby promoting the concept of decentralized mini-grids. So maybe Aonghus, you might comment on that. And I know that one of our demonstration sites, of course, is addressing particularly that kind of challenge.
Yeah. Okay. So I'll be positive and negative to Carlos. On the positive side, I think it should be obvious to us all that it's technically feasible to scale up community energy. It's not a complicated concept, and technology exists, and it can be done. But I think what is difficult, the negative part, is that maybe this relates to the policy part that Laura spoke on, or the filtering of the policies down into regional levels, in that even though in the European Union likes uniformity, we end up with many different interpretations of the same rules. And so my experience of community energy schemes that have been successful is that they have generally involved some kind of champion or champions who have managed to resolve the many non-technical challenges that there are. Okay, and so we have come across some of those in our own demonstration sites. In Ireland, we come across policies that don't exist in Spain around running private wires across roads and things that seem counterintuitive at the local level, but perhaps at the macro level have got some logic behind them. So I think in community schemes of various kinds that I've seen, success comes down to the desire of drive of the community rather necessarily than the lack of technology to put things in place. I've come across that in energy and housing, all kinds of things. So so that's a sort of in summary, could it be scaled up? It depends on the community, I would say.
And the appetite of the community. And Carlos has just come back in the chat and he says, I ask because nowadays there are EU funds in Portugal to promote such energy communities. And I'm familiar with at least one other research project, Power Ecom, which is looking at renewable energy communities. And if I maybe direct Carlos's question to Rodolfo. Rodolfo, could a modular and portable solution that you've explored in the context of the port operation, could that be used in ecological islands or rural villages?
Yeah, we only have to find the right place that we can combine all the sources. But of course, that's the origin. No, now we are in the port because we found a spot where we have wind. And the ports are always wind. It's very sunny, and we have the river and we have the tidal, so we can combine three main energies, and then we can play with the pump-as-turbine to operate when there are no sun, when there is no wind. So we can. We found a really special place where deploy the container. We can put everything inside, we can rent a truck, and we can go to Portugal. I would like to come back and explore where we could deploy the system. It would be perfect, but we have to know that as you could see in my presentation, the energy that we harness is not so big. So the community must be not very big, but for basic consumptions like light in the street, like some I don't know, maybe some pump for water, some specific uses. It would be perfectly solved with this system, of course.
Yeah, very good. And I guess there might also be the opportunity to deploy Naufal's fish-friendly turbine, pump-as-turbine in a system like that. So if I spin the questions around a little bit, and I know that there are some commercial people in our audience this morning. And I'll ask in terms of Aonghus or Rodolfo or Naufal about commercializing the results of this particular project. How far away in technology readiness levels, Aonghus, are we from the kinds of technology being developed and hybridized here? How far away are we from being able to commercialize some of these solutions?
Yes, Paul. So that answer varies depending on which aspect of the project we're talking about. So if I divide it into two major contributions, one was developing a software for designing hybrid renewable energy systems from the point of view of, well, we have this amount of wind and this amount of sunshine. How would we size it for local conditions? That was completed and demonstrated. I guess it would be very high up the technology readiness level scale. The next major contribution is on managing those renewable energies. So we have installed a system and we're monitoring how much of each we're producing and how much we need and trying to forecast into the future. That being the topic of some of our upcoming webinars. That is also well advanced, but not as well advanced. And then in terms of some of the hardware that we have worked on, we can see, for example, in Naufal's presentation, we have made some progress, but it would be still an early stage development, that fish-friendly turbine machinery. Rodolfo's port pilot scale, well, I think we've gone to the stage of demonstrating, but there are still lots of things that I see Rodolfo nodding that we could do to improve that. Yeah. So perhaps that's 60% of the way along the scale, something of that nature.
Yeah, thanks, Aonghus. Rodolfo?
Yeah, I absolutely agree. There is a lot of way to run still, but well, step by step. Just the limit of the source that we can harness. That's it. We need to find the right place. Indeed. And we adapt.
Yeah, thank you. And Naufal, with your fish-friendly pump-as-turbine, how far away are we from commercializing this particular component of the overall system?
Okay, thank you, Paul. I agree with Aonghus and Rodolfo, and specifically for the CSP-80, I don't think that it can be commercialized in the short term because of we still need more research, especially we need to assess how fish friendliness the CSP-80, because of until now we just assess for the performance. We don't know how the fish friendliness in the turbine mode, and also we need to know if we're doing the geometry modifications. We need to know also the performance in the pumping mode. So it's still the early stage, like Aonghus said before. So we need more time. Maybe in the medium to long term, maybe it can be commercialized. But for now, we're still doing the research to make it more mature technology.
Yeah, very good. So in a way, taking what Aonghus said about if we have an overall system, these systems, these renewable energy systems, and in particular the hybrid renewable energy systems, they're all composed of individual elements. And some of these elements are quite well developed, and their interaction with other elements is quite well demonstrated. Others are at an earlier stage. So it's a very rich and fertile area for continuing research and continuing impact. As we come near the end of our webinar, maybe I'll go around the table to each of our contributors this morning and just ask, so what have you learned from participation in this project, and what would your hope be or plan be for a next step or stage to develop our understanding of hybrid renewable energy systems? So maybe Laure, let's start with you. We'll do it in the sequence in which we had our presenters.
Okay, thank you, Paul. Well, from my side, it was very interesting to see the differences, but also the common challenges within the different countries, and how the topic of renewable energy and the hybridization and also the combination and the storage is a very hot topic right now. And I think the project arrived really at the right time. And we really have to work on that, and also on the policy context, to see how we can facilitate the implementation and how we can provide some evidence-based argumentation for policymakers. So that was very interesting. And if I can just answer the question that was in the chat, Paul, if you allow me, there was a question regarding what happened in Spain in 2025 with the blackout and how it changed or not the policy in Spain. The thing is that well, I'm not a specialist of grid and electricity grids, but from what I understood is that the problem came more from a combination of voltage issue, the grid instability, and some disconnection in the system. And rather than questioning the renewable energy policy, it strengthened it. And the question was more how to integrate it better and how to work on a storage facility to avoid those issues. But I see, Rodolfo, perhaps you can also answer this question because you're more involved in that. So that's more a question of how we combine and how we have the structure to prevent those blackouts.
Still, it's not clear completely what happened in Spain, but I'm afraid that the net is used to have another kind of electrical system, and we need to increase the budget to adapt as fast as possible the variability of the renewable, because we know that it's not a constant electricity. You get high and down peaks about the energy that you produce, and the old system is not used to or cannot manage very well this variability. So we have to invest, we have to renovate, we have to make it young net, and it's not a thing that you can solve in not even in 5 years. So we must be patient, and on the other hand, we cannot stop going on developing things in renewable energy, because it's clear that is the future. And we didn't say anything about the wars and how much impact on the energy system, but it looks unfortunately that we are entering in a period free of peace. So we should give our best to go on developing and going on the the renewable energy, because it's the only way that we could survive whatever happens in the world.
Thank you, Rodolfo. And Aonghus, what have you learned in your role in the project?
Many things, Paul. I'll pick one. I think from when the project was envisaged, which was probably back in 2022 to today, I think what can be done with digitalization in renewable energy and in many other places has changed quite a lot. And the capabilities that researchers and technology developers now have moves the dial a bit on what we can achieve. That helps what we were trying to do in HY4RES. I think that has been a learning curve for me. But it also of course creates its own other problems. We discussed data centers and them consuming more than 20% of Irish electricity, for example. We didn't mention how much water they consume. So there's never a simple perfect solution to a complex challenge, and we always have other things to solve. But digitalization, I think, is quite a cross-cutting transformation of industries.
Very good.
It's quite visible in the last 4 years.
Yeah, thank you. And Naufal, just to finish with you briefly, you have your research career ahead of you. So what have you learned from this experience of a project that's involved many different technologies and many different partners from different countries?
Yeah, thanks, Paul. Firstly, it's very, very interesting experience. I mean, like, we can see that there's a lot of potential of renewable energy, like in Spain, in Rodolfo sites, there is a lot of potential that we can manage. And also talking about the policy context, also we need the policy to direct our technology. So technology and policy need to be together. And also, like, when we see the project itself, like when we implement the technology to the sites, of course there is a lot of problem, but here we are to solve that problems, to make it like fit, to make it like environmental friendly and technological ready. So it's really interesting and in a lot of experience, to be honest.
Yeah, very good. Thank you. So as we come to the end of our seminar and our webinar, I guess one way of reflecting on what we've been talking about for the past hour and a half is from you've seen an example of two modes of knowledge production. Mode one, which is good scientific research and good scientific knowledge production. But mode two is the development of new knowledge in the context of application. And HY4RES is a great example of that. We've heard about the policy targets and how demanding they are, how HY4RES is a transdisciplinary research response to that as a project. We've heard about how the pilot that we've developed demonstrates what's possible. And finally, we've also seen how we're careful to make sure that we mitigate any risks associated with deployment. We invite you, thank you for joining with us this morning. We invite you to join our community, follow us on LinkedIn, and this is the first of 3 webinars. The next ones coming up are on the 16th of June, where the focus is on supporting decision making. And on the 30th of June, turning research into practice. For both of those, you will find the link in the website. And thank you again to our wonderful presenters who've put a lot of thought into their presentations and for answering the questions this morning, and to you, our audience, for joining with us in the seminar. And finally, to Amandine and Nina for their great work behind the scenes as well. Thank you very much.